Welcome guys, so keep solving our physics subject here. Be sure to subscribe to my channel. So 21, the period of a physical pendulum is this. Okay, so fortunately I have proved this formula in other videos. You can go to check it. I think it's in the GR. This problem 61. I have proved this formula rigorously. Use the Lagrangian equation. Okay, but luckily somebody already tell you the answer. So 21 is very easy. Basically, it's a circular hoop has over, so you have a loop, and basically you know the loop has momentum inertia, basically mr squared. But what we need is the momentum inertia related to this point. So due to the parallel theorem, we just add mr squared from here to put in here. So we have 2 mr squared. Okay, so the period is trivial at 2 pi over 2 mr squared divided by mgr, which is 2 pi squared 2r over g. So 2 pi times 20 centimeters divided by 10. So close to 1.2 second. Okay, very trivial. So answer is C. Answer is C. Okay. Okay, so 22 say that the curvature of the Mars is such that its surface drop the vertical distance 2 meters every 30,000 meters tangential to the surface. So in addition, the gravitational acceleration near its surface 0.4 times the nearest surface of the Earth. What is the speed of golf? What is the speed of golf? Ball would need to orbit Mars near its surface. Okay. Okay, so let me try it again. Oh, I just want to draw a pretty good sphere. Okay, unfortunately this is not sphere, but from here to here it says you just move 2 meters, and this is 3600, and this is r. This is r minus 2. So from the Gogu theorem, tell me that which r is approximately this one. Okay, we don't compute it. Okay, until we do the final calculation. And they ask about what. They also tell you that the gravitational force is 0.4 times 10, which is 4. And what you need is if the golf is rotation. So simple. So golf contains the so-called circular motion is equal to the force. So v squared is square root of gr. V is square root of 4 times. Okay. So 0.4 times 10, which is 4, and 2 meters to this, you can solve it, and all you get is, let me see, so your g is 0.4 times 10, which is 4, and your radius basically from, sorry, so this one is r squared minus 4r plus this one is r squared. So basically this is over 4. So v is just this one, m over s, so it's 3.6 kilometers over s. Sorry about this. This is over 4. My computation is too fast. So the answer is C. Your answer is C. Okay, 23. You have some strange force, which is 2 plus epsilon. Okay, so total magnetic planet will be conserved. Correct. Right. Momentum conservation, mechanic energy conservation is fixed. Angular momentum is still fixed. B is correct because angular momentum, because your force is only radial dependence, so angular momentum is still conserved. C, the period of the circular orbit will be proportional to 3 plus epsilon divided by 2 power of their respective orbital radii. Okay. So this is the mv squared divided by r. Basically it's m. So we just use the definition. V is omega r. Basically it's 2 pi over t over r. So basically it's m 4 pi squared r squared. Oh, sorry. So this is for okay. So we have mv squared over r. So v is omega r. Basically omega is 2 pi over t times r. So this is m 4 pi squared r divided by t squared equals to some constant base gmn divided by r2 plus epsilon. So this tells you that r3 plus epsilon divided by t squared is constant because n deleted, so this is constant. So basically your period will proportional to this 3 plus epsilon divided by 2. So C is correct. D, the single planet will have a stationary non-circular. Okay, so stationary is not correct. So theorem. Basically this is called a Bertrand's theorem. Bertrand's. Trands theorem. So basically the only R dependence force, suppose Rn have stationary orbit if n is 2 or minus n is minus 2 or plus 1. So that means only harmonic oscillator, basically Kr, or the standard Newton force have circular orbit and stationary. So D is not correct. D is not correct. So the answer is D. Okay. So 24. Two identical conducting sphere, A and B, and then there are also some guy C. The initial separate distances so basically have the same charge, and they have the force, which is called that's called F. And after that, add the third conducting sphere is uncharged, and sphere C is first touched to A. So when you touch to A, then they separate their charge. Okay, when B and when then you touch to B. So when you touch to B, then you still separate the charge. So Q plus Q over 2 is 3Q over 2. Then you separate it, so it becomes this one. Why they separate the charge? Because they have the same capacitance. So when they touch together, they will form the same potential. So that means they have separate charge. And then you say, what is the force between A and B? What is the force between A and B? So the force is just proportional to the product of the charge. So now these two products 3 over 8 Q squared. So the force is 3 divided by 8 F. So the answer is D. The answer is D. Okay. So 25. Nice. The question is too long, so you can read by yourself. Basically, you have two capacitance. There is a circuit, blah blah blah, and the energy stored in the capacitance U1 and U2, and which following are states they are incorrect. Okay. So initially you have some states capacitors, the energy stored in U naught, and after switch close, the capacity C1 carry charge Q1 and Q2. Okay, so okay, so which one is incorrect? So in the beginning, if the switch is open, then C1 is charged. So that means Q naught is equals to C1 times V. Basically, okay, let C1 is equals to C. So this is CV. And the U naught just half CV squared, or basically Q naught squared divided by 2C. Okay, and after that, the S goes to here, then two of them have the same potential. So now two of them have the same potential, and the Q1 is CV, Q2 is CV. So definitely Q naught just half of Q1 plus Q2, because this is CV, this is CV, CV. So the A choice is correct. Okay, B. Q1 equals to Q2. Right. Q1 is CV, Q2 is CV. So simple. So V1 is V2. Trivial, right? U1 is U2. Trivial. So remaining is E. And E is not correct, because the potential the energy proportional to the volume square. So basically, in the beginning you have this, but in the final you have this plus this. This is U1, this is U2. So U1 plus U2 basically is 2U naught. So E is not correct. So the answer is E. Okay, 26. ILC currents. Somebody give you the what? Capacitance. Ask you how to estimate capacitance. So basically, one important formula I already said many times is that the resonant frequency is 1 over LC. So basically, you have this omega now, and you have L now, and you don't know C. So basically, C just approximate to over L square 1 over LC. So C is approximate to 1 over L omega square. So we can compute basically is 1 over what's L? L is microhenries. So 2 times 10 to the negative 3. Oh, it's micro. Okay, so 10 to the 6 times the frequency. Remember frequency you need to times 2 pi. So basically it's this one. So C is close to 10 to the negative 12. So 10 to the negative 12 in the electronics are called picro. So picro means that 10 to the negative 12. Okay. So 27, some plots as he asks you about which one is correct. Okay, the first one, dn over dt is exponential minus 2d. This is called semi-log. This is correct because there are exponential terms. So when we take a log on this part, then you can get minus 2d. And the B, linear equation. Vs and F are linear. So use linear, good. And S is t squared. We take log. And the reason is that, okay, so let me summarize the important thing. Usually when you have A equals to AX to R, and you use the log plot, then it will become what? Then it will become linear. So this is suitable by using log plot. So this one is suitable for using log, and this is linear, and this is not good, right? This is p to t to the fourth. So what p to e to the fourth? What should we use? What we should use is the log plot. This is log plot is okay. So d is not correct. This is 1 over omega. 1 over omega should use also use log plot. Should also use log plot. So answer is D. Okay, I think it's enough for today, and I will see you guys in the next time.